So a surd is simply a square or nth root that cannot be expressed as a rational number. For example, let's say we have square root of 2, square root of 3, let's say we have cube root of, let's say 10, cube root, let's say of 42. So these cannot be evaluated directly. In short, they are irrational numbers. So since they are irrational numbers, they have been categorized to be the surds. However, there is a method, or there are methods we can use in order to simplify such. So let's work on some of the rules. So there are three basic rules that we have to understand when it comes to working with surds. Okay, the first one is the product rule. So according to product rule, when you are multiplying the values in the roots, you can simply multiply them under one root as well. What I mean is this: let's say we have the square root of a, we are multiplying this with the square root of, let's say, b. This can also be multiplied in the same root, that is a multiplied by b. Of course, we know a multiplied by b is ab. So this and this is just the same according to the product rule. Let's look at the quotient rule. Quotient rule is simply where we divide the given values, okay, or the given irrational numbers. Let's say you are dividing a divided by, let's say, root of b. We know this is the same as root of a divided by the root of b. Now, according to the rule, you can divide them using the same root or under one root. So in this case, it's the same as saying a divided by what? By b. So this is the same as this. Okay, so these rules are very, very important when it comes to simplifying the surds. Now, what about the scalar multiple or the sum rule? What happens when you are adding or subtracting the scalar numbers? You simply add or subtract the scalar numbers and then you factorize the given root value. A scalar number is simply a number which is outside the given roots. For example, let's say we have c root of a. Let's say we are adding or subtracting. Let's say we have d, and then here we have the square root of a. The values c and d are referred to as the scalar numbers. Now, according to the sum rule, you simply add the scalar numbers first and then factorize the root values. So in this case, we have the square root of what? Of a to both sides. So in this case, we are going to have the square root of a. So this is according to the rules. So make sure that these three rules have been known. Okay, know them by heart, because whatever we are going to be doing down there will be based from these rules. So let's say you have been asked to simplify, let's say root of 8, let's say multiplied by 2, root of 2. How can you simplify such? Now, according to the product rule, when you are multiplying the values separately using the same root, you simply multiply them under the same root. That is 8 multiplied by 2. And 8 multiplied by 2 is what? 16. So it's 16 here, and the square root of 16 is 4. So we have 4. So this is the answer to such kind of equation. Let's look at the quotient rule. Let's say we have been given the square root, let's say, of 78 over the square root of, let's say, 6. How can we find the value of such? Now, according to the quotient rule, when you are dividing the roots, the same roots separately, you can divide them under one root. So in this case, we have 78 divided by what? 6. Now, to simplify this, we can divide 6 into 78, and we know it goes exactly 13 times. So we are going to have the square root of what? Of 13. So we are just going to end here because we cannot perfectly evaluate this irrational number. So it's just going to be the square root of 13. However, if we had a perfect number, let's say 16, we could have found the value because we know square root of 16 is 4. So in this case, since we cannot perfectly find the square root of 13, we can just end it up to there. Okay? However, if you have a calculator, you can go ahead and find the square root of 13 using a calculator. Okay, so in this video, when it comes to Surds, we do not use the calculators. Hence, we are going to solve in such a manner without using the calculators. Okay, so let's look at the third example using the scalar multiple or the sum rule. Let's say you have 11, and then here we have, let's say 5, let's say minus, here we have 4, and then we are multiplying with the root of 5. How can we go about this? So, according to the scalar multiple or the sum rule, you first have to deal with the scalar numbers. So, in this case we have 11, and the sign we have here is simply subtraction. If we had addition, we could have added, but since it's subtraction, we are going to have minus here, and then 4. Now, since we have the same values here and there, you can factorize and just write one value. Of course, it's 5. So 11 minus 4, it's what? It's 7. So we have 7 and then root of 5. So this is the answer to the question. So this is how we simplify when we have been given values using those same rules. If you have observed, all these have been answered using the same rules. So those rules are very, very important to know them. Let's look at another example. Let's say we have 20, and then let's say we are multiplying with the root of 3 multiplied by root of 3. Let's say multiplied by again root of 9. And then here let's say we have minus 16 here multiplied by, or let's say open brackets, and then we multiplied by 9, and again we multiplied by root of 9. So how can we simplify such? Okay, so let's say we also have the denominator down there. Let's say we have root of 8 multiplied by root of 2. So we may go ahead and try this one. So just pause the video and try it out. So in this case, let's first simplify whatever we have in the brackets. Okay, so in this case we have 20, and then we know when you are multiplying separately using the same roots, you simply multiply the values in the same root. So in this case we are going to have one root, then 3 multiplied by 3, then multiplied by what? By 9. Okay, minus what we have outside the brackets, that's 16. And then here we are multiplying the same roots. So that is root of 9 multiplied by root of 9. We know under the same root, we can multiply them as 9 multiplied by 9. Okay, over. Okay, then the root of 8 multiplied by the root of 2 can also be simplified as 8 in the same root multiplied by 2. So let's wrap the top part here since we have already simplified the given expressions. So in this case then, we are going to remain with 20. Okay, then root of, when we multiply 3 multiplied by 3, we are going to have 9. Then 9 multiplied by this 9 here, we are going to have 81. Okay, and then minus 16 outside the brackets. So we have root, then 9 multiplied by this 9 here, we are going to have 81. Okay, so we cross and then over. Down there we have the square root. So 8 multiplied by 2, we are going to have 16. So here we have 16. So let's now wrap the down part here. So in this case, we have 20, and then since we have the scalar numbers, which of course we know by now are numbers outside the roots or the brackets, in this case then we are just going to deal with the scalars alone, that is 20. The sign we have here is subtraction, so we are going to have 20 minus 16, and then since we have the same values in the square root, we are simply going to write only one value in the square root, that is 81, over the square root of 16. We know it's what? 4, so we have 4 down there. So this is equal to, now 20 minus 16 is what? Is 4, so we have 4. Then we have the square root of 81 over 4 down there again. So in this case, 4 and 4 will cancel, and then we are just going to remain with what? Square root of 81. And the square root of 81 is simply 9. So this is the answer. So this is how we simplify, and then we have our answer as such. So you first simplify using those same rules, and then you have your answer. So basically, the rules are what's guiding us into understanding what surds are, or how we can simply simplify the given surd. So let's say you have been given to simplify root of 27. So to simplify the root of 27, you simply have to find the values which you can multiply 27, and then you have, or rather, which you can multiply the values and then have 27. So what values can you multiply for you to have 27? So in this case, we know 27 is as a result of the multiplication of 9 multiplied by what? By 3. 9 multiplied by 3 is 27. And by the product rule, we know this is the same as root of 9 multiplied by root of what? Of 3. And root of 9 is what? Is 3. Okay, and then we have 3 outside there. So this 3 cannot be found as the perfect square. So let's look at 2 more examples before we go into understanding how we can rationalize the denominator of the given irrational numbers. So in this case, let's say we have been asked to simplify, let's say, root of 512 minus 15, and then root of 2. So how can we simplify such? Now, we have been given a clue that we have the root of 2. So we have to simplify this value here such that we are going to have the root of what? Of 2. Now, we know that 512 is as a result of multiplication of 2 multiplied by 256. So in this case, according to the product rule, this is the same as 256 multiplied by 2 minus 15 here, and the root of what? Of 2. So in this case, when we multiply 256 by 2, we are going to still have 512. And according to the product rule, writing like this is the same as writing them separately. So in this case, we are going to have 256 multiplied by root of what? Of 2 minus 15 root of 2. So what is the square root of 256? The square root of 256 is 16. So we have 16 root of 2 minus 15 root of 2. So if we have the same roots and the scalar numbers outside the roots, remember the rule of the sum rule, what are we supposed to do? So if we have such, we know that if you have such, we simply have to write the values outside the roots, that is 16 minus 15, and then the root of 2 outside the brackets. So 16 minus 15, that is 1, root of what? Of 2. So 1 multiplied by root of 2 is simply root of 2. So that is the answer. Okay, so let's look at one more last example before we go into understanding how we can rationalize the denominators. So in this case, let's say we have 5, and then let's say root of 75, and then let's say we have plus 2, and then root of 3. Now if we look at this, we have 75 here, and we also have root of 3. Which one can we make easier for the other to result? Okay, we know that this cannot result into the root of 75, but 75 can result into the root of what? Of 3. So let's do that. So we know that this is the same as 5, and then in the root, for us to have 75, we know this is the same as 25 multiplied by root of 3. Since here in this case we have the root of 3 this side, it means even here we have to make it in such that when we simplify, we are going to have root of 3. Okay, so here we have plus root of what? Of 3. Okay, so in this case we have 5. Now we know, according to the product rule, when you have the values in the same root, we know we can write them separately. So we have 25 multiplied by root of 3. Okay, then plus 2 root of what? Root of 3. So in this case we can multiply, or rather find the value of the root of 5. We know root of 5 is what? Is 5. So in this case we are going to multiply with 5, and then we have root of 3 plus 2 root of 3. So 5 multiplied by 5, here we have what? 25. So we're going to have 25 outside the brackets, and then we have root of 3 plus, we have this 2 outside here, so it's 2 root of what? Root of 3. Now we have the scalar numbers outside the brackets, or rather the roots. So in this case we are going to add the scalar numbers first according to the multiple scalar rule. So we have 25 plus what? Plus 2, and then since we have the same roots, in this case we are going to write on one root, that is root of 3. Then 25 plus 2, it's 27, so we have 227 rather, then root of 3. So this is the answer. So this is basically how we simplify different given values of the surds. Okay, now let's discuss how we can rationalize the denominator. So how can we rationalize the denominator? So for these ones, I will explain them using examples. Okay, so let's say you have 3, then we have root of, let's say, 5, and then we have over, let's say we have 2, and then root of 6. What can you do if you have been asked to rationalize the denominator in this case? Okay, so to rationalize the denominator, you simply have to multiply with the root of the denominator. Both the numerator and the denominator should be multiplied by the root of the denominator. So in this case, you have to multiply the numerator, that is 3 root of 5 over 2 root of 6. So in this case, the root we have is root of 6. So we multiply with the root of 6 to both the numerator and the denominator. So in this case then, we will have 3 root of what? Root of 5 multiplied by root of 6 over 2. When you are multiplying the same roots, the same values in the roots, you simply write the value. Take note, the same roots. For example, you have root of 6 multiplied by root of 6. We have the same square roots to both sides, and we also have the same values inside. So in this case, the answer is simply 6. So this is how you get the answer when you're multiplying. However, this does not hold if we, let's say, we had cube root. So these are different. This is a square root and this is a cube root. So you cannot take the value as I had talked about before, unless where you have the same roots. Let's say cube root multiplied by the cube root of 6. In this case, the value is what? Is 6. So this is how we go about it. So in this case, since we have square root of 6 multiplied by square root of 6, it's simply what? 6. Okay, and what is 5 multiplied by 6? It's simply 30. So we have 30 over 2 multiplied by 6, it's what? 12. Okay, so in this case, we know we can simplify this further because 3 can go into 12 how many times? 4. So in this case, we have root of 30 over 4. So this is the answer. So this is how we go about these kinds of rationalizing the denominators. Now, what if you have the denominator which has a sign? Let's say you have 10 over root of, let's say, root of 3 minus 1. How can you rationalize the denominator? So make sure that you subscribe to the channel, you like the video, and also share it to others so that they may also get the understanding of the surds. and also more videos are available on the channel, so make sure that you subscribe and look for other topic videos as well. So to rationalize this one, you simply have to multiply with the opposite sign of the denominator, both the numerator and the denominator. Okay, so to both you multiply with the opposite sign of the denominator. So in this case then, you simply multiply the numerator with root of 3. So in this case, since we have minus, you simply write positive even down there. So we have plus 1. So in this case, we have 10 multiplied by root of 3 plus 1 over, down there we have root of 3 minus 1, and also we multiply with the root of 3 plus 1. So you simply multiply with the opposite sign of the denominator. So this is how we go about this one. Make sure that you understand that concept. So in this case, we have 10 and then root of what? 3 plus 1 over. Now we can simplify the denominator. We can simply multiply this root of 3 throughout here and also negative 1 throughout here, according to the rules of simplifying the given product of different algebraic expressions. So in this case, we are going to multiply root of 3 multiplied by root of 3. I talked about this before. When you are multiplying the same root values, you simply write the value in the bracket, in the roots. So in this case, it's just simply 3. And then root of 3 multiplied by positive 1, we are going to have positive root of 3. And then negative 1 multiplied by root of 3, we are going to have negative root of what? Of 3. And then negative 1 multiplied by positive 1, we are going to have negative what? Negative 1. So in this case then, it's a lot here, so let me just wrap this part here so that we can, we can understand and see everything clearly. So in this case then, we have 10, open brackets, root of 3 plus 1, okay, over. So here now we have root of 3 minus root of 3 is simply 0. So we have 3 and negative 1. And the 3 minus 1 here, we are going to have what? 2. So we are going to have 2 there. So 2, can go into 10. How many times? 5 times. So we have 5 and then root of 3, then plus 1. So this is basically the idea behind the rationalizing of the denominator. So make sure that you understand fully what this is, and also go through different kinds of videos, or rather questions, so that you understand more. Otherwise, this is all for this video. Thanks for watching to the end. Remember to subscribe, like, and share the video to others as well. Stay blessed.